Welcome back. In our last explainer, we looked at the raw physical power behind TSMC's dominance. Today, we're going a level deeper. We're going to explore the company's nervous system, the hidden feedback loops that let it learn, adapt, and just plain outmaneuver every single competitor on the planet. So just as a quick reminder, in part 1, we really dug into the visible foundations of TSMC's dominance, what we called its engine of precision. We talked about its massive synchronized capital spending, how it can build multiple state-of-the-art fabs all at once, almost as if money is no object. We also saw how its pure-play neutrality makes it the one and only trusted partner for fierce rivals like Apple, NVIDIA, and AMD. And finally, we looked at how its entire ecosystem in Taiwan operates like a single, hyper-responsive organism. Okay, so those 3 pillars built the machine, right? But what keeps it learning? How does it keep getting better without slowing down? Now we're going to move beyond those surface-level mechanisms and look at the hidden systems that sustain TSMC's lead, what we're calling its cooperative brain. We're going to break down the 3 connective tissues that let TSMC learn and adapt faster than anyone else, turning its initial precision into something permanent. All right, let's dive in. So our first topic is TSMC's really unique approach to R&D. You see, most companies treat research and manufacturing as 2 totally separate worlds. Well, TSMC just fused them together. This slide really gets to the heart of a fundamental difference in philosophy. See, competitors like Intel develop their new processes in these isolated labs, like their famous D1X in Oregon. Once they think they've perfected it, they try to copy exactly that recipe to their high-volume factories. But this creates a lag, a lab-to-fab gap, where things that worked perfectly in a controlled lab environment can just break under the chaos of real-world production. TSMC completely eliminates this gap by doing its R&D right inside its busiest, highest-volume factories. And this isn't just some abstract idea. It's a meticulously engineered system. Inside a fab that's already running millions of dollars of commercial chips, TSMC operates what are called shadow lines. These are basically experimental production lines running right alongside the main one, testing out next-gen tech without risking a single customer wafer. Engineers from suppliers like ASML and Applied Materials, they aren't just visitors, they're practically residents, embedded in the clean rooms, tuning their gear on live production. And get this, key customers like Apple are invited in to help develop their future chips on these pre-production nodes, which means their next iPhone is literally the vehicle for learning and improving. All of this just creates a fire hose of data that feeds a massive, centralized AI, allowing TSMC to learn from every single wafer in real time. Now, this whole integrated R&D thing flows directly into our next point. See, TSMC's dominance isn't just about shrinking transistors anymore. It's about how you connect them. We're talking about advanced packaging, and TSMC has turned this into an absolute fortress. You might have heard these acronyms being thrown around: CoWoS, Info, SOIC. These are TSMC's signature advanced packaging platforms. CoWoS, for instance, is the magic behind the most powerful AI chips from NVIDIA and AMD. It lets them stack high-bandwidth memory right next to the processor, creating this incredible, super-fast connection. Now, the technology is absolutely world-class, don't get me wrong, and competitors like Intel and Samsung have their own versions. But the real uncopyable advantage, it isn't the tech itself. It's the ecosystem that TSMC has spent years painstakingly building around it. So here's the crucial part. TSMC created this platform called the 3D Fabric Alliance. And this is not just a list of suppliers. Think of it as a federated partnership. You have dozens of companies, from design software vendors like Cadence to substrate makers, all working from a single shared roadmap. They sync up their design rules, their simulation models, their production standards. And what this creates is a powerful network effect. The more partners that join and optimize for TSMC's platform, the harder it is for a customer like NVIDIA to ever even think about leaving. It's basically an industrial version of the App Store. The cumulative value and compatibility create an unbreakable lock-in. Okay, this last piece of the cooperative brain is maybe the most profound. It really gets to the financial heart of TSMC's strategy. It's all about how TSMC turns its supply chain from just a list of vendors into a distributed R&D army that works for them. This quote just nails it. Most companies have a pretty simple transactional relationship with their suppliers. You pay, they deliver. But TSMC realized a long time ago that the bottleneck to its own success was actually the weakest link in its supply chain. So it turned that relationship into a deep, symbiotic partnership. And this illustrates the self-reinforcing loop, the flywheel that this creates. It's actually brilliant. Step 1. TSMC invests billions directly into the R&D of its key suppliers. We're talking about companies making critical chemicals or super specialized parts for EUV machines. In return, those suppliers align their entire R&D roadmap with TSMC's future needs, and again, embed their best engineers inside TSMC's fabs. The payoff? TSMC gets first and often exclusive access to custom-tuned innovations. This makes their performance and yields improve way faster than anyone else's, which of course attracts the world's best clients, which generates even more capital to pour right back into the top of the flywheel. And what you get is something the source material calls a fused research frontier. It's a state where dozens of technically independent companies all start acting like one giant distributed brain. So while competitors like Intel and Samsung can go buy the exact same EUV machine from ASML, they're getting the off-the-shelf model. TSMC, on the other hand, is getting the bespoke, custom-tuned version that was born from years of this deep, co-funded R&D. And that gives them a massive head start in the race to keep Moore's Law alive. So you see, the crucial point here is that these three strategies aren't separate things. Integrating R&D into live production, building this huge packaging alliance, and funding the innovation of your entire supply chain, they're all interconnected systems. They're the synapses and the neural pathways that allow TSMC to think, learn, and execute like a single intelligent organism. We've seen the physical engine of TSMC, and now we've uncovered its cooperative brain, the systems that keep it coordinated and always improving. But how does this incredible economic and industrial machine become undeniable geopolitical leverage? In our next and final part, we're going to explore how a company's structural advantages can become a nation's most powerful diplomatic tool. Join us for Part 3.